So now that we know what Apache Iceberg is and how it works, let's talk about the features that this functionality then, well, brings to the table. Like, why would you want to be using Iceberg? These are the good things, the value adds. And that includes things like ACID transactions, probably the primary reason. So again, one of the really nice things about databases and data warehouses is ACID guarantees, where basically you have certain things that you know that the database is going to take care of that you don't have to worry about. So things like atomicity. So atomicity just means, did the transaction happen or it didn't? Meaning there's no partial transactions. I'm not going to like halfway add data, stop, and then you're going to have like half the data added to the database. Basically, the transaction doesn't commit until it's 100% done. And if it isn't 100% done, it didn't happen. Okay, that's atomicity. It either happened or it didn't. Then there's consistency. Okay, basically the idea that if two people are asking for the same table, that they're both going to get the same version of the table that is current at the time of them sending the query. Okay, isolation. That when people are operating or doing work with the table, that their work doesn't affect other people's work. So they're all isolated. Okay, and durability, that the data is persisted and will exist later. Okay, so all these things are sort of addressed by the structure of Apache Iceberg tables, making the ability to use your data lake storage pretty much like you would a database. So even though a data lake is not a database or a data warehouse, it's not this sort of bundled software package, the Apache Iceberg metadata provides this glue so that way different softwares can interact with each other and achieve sort of the same result. So the idea is you get this sort of decoupled, deconstructed data warehouse. Hidden partitioning. So again, partitioning is the ability to say, I want you to break up the data files as you write them based on a certain value. Okay, so traditionally what happened is when the old standard, which is the Apache Hive tables, existed, what you would do is you would specify a specific column. Okay, and then every unique value got its own partition, which was a subfolder. Okay, so that's how you would identify, hey, which files were which part of which partition, because there'd be a subfolder for value 1, a subfolder for value 2, and all the files for that value would be in those folders. But the problem with this is when you ran into things like a timestamp column. So have you ever seen a timestamp data? It's hours, days, or days, hours, minutes, so, all the way up to like nanoseconds. So the problem is each nanosecond is a unique value. So if you were the partition based on the timestamp, you would end up having a subfolder for every nanosecond with probably like 1 or 2 records, which would actually make reading your data very slow because you're going to have so many more files, which means more files for the engine to open up for certain queries, that it's going to run a lot slower. So usually what you would do is that when you design the table, you would take that timestamp column and make another column, like an hour column, a month column. But you, as a data engineer, would have to make sure that when you get the data coming in, that you would have to convert that timestamp to an hour or a month to write to the table. So that way you can get that partitioning. And then the analyst or data scientist on the other side, when they were to use SQL to query for that data, they would have to explicitly say, not only do I want a timestamp between this range, but I also want data that's within this month range or this day range, because they have to explicitly refer to that partition field. So this made partitioning a little bit trickier. But with Apache Iceberg, both of those things don't need to be done, because the partitioning is tracked in the metadata, and you're allowed to express that, hey, the way this table is partitioned is based on the transformed value of the field. So instead of creating an additional column that you store in all your files, which actually ends up resulting in you storing more data, what you can do is you can say, hey, this timestamp field here, I want you to, as you evaluate the table, convert it into a month, convert it into a day value on the fly, and use that to determine sort of which files belong in what partition. Okay, so it's all sort of done in the metadata. The actual data files don't actually have the partition values. They just have the raw value that gets transformed for the metadata. Okay, and this does 2 things. One, when you're doing data ingestion, you don't have to derive a whole new column, so you don't have to write that extra logic in your code. And if you're that data analyst or data scientist, just by asking for a range of the timestamp, you're going to get the partitioning benefits, because the engine will know, oh, this table is partitioned by the transform value of that column that timestamp column that you refer to. So that makes it easier for the analyst to not accidentally scan the full table, which means they're not going to accidentally get super slow scans because they didn't add some extra bit to their query. So this just makes life easier, bottom line. Okay, just makes everything more intuitive, prevents mistakes from the data engineering side and the data analyst side. So it's a very powerful feature and a very unique feature to Apache Iceberg. Partition and schema evolution. So there's two things that can change in the life of a table. Okay, there's a schema. So maybe you need to add columns of data because you decide to track more data, or you need to change the name of a column, or change the data type of a column, or even remove a column. Well, these are all things that can be done because the schema is tracked in the metadata. So in that case, if you change the schema, even though the old data files might have been written with the old schema, the engine can then superimpose the new schema because it's aware of it from the metadata. And then two, a feature that's actually really, really unique to Apache Iceberg is partition evolution. So again, the way you actually split up the data files, the partitioning, usually you can't change that. Okay, historically and even in other modern formats, you cannot change that. If you want to change the way the table is partitioned, you would have to rewrite the whole table. You have to rewrite all the old data files to match the new partitioning style. But in Apache Iceberg, since all the partitioning statistics are inside the metadata, in a situation where you decide you want to change how the table is partitioned and how future files are written, you could just change it. All future files are written with the new partition specification, and the old files can remain in the old one. You can rewrite them if you want, but you don't have to. And the beauty of it is, because it's all in the metadata, the engine will know, based on the metadata, that these files were written with the old partition specification. These data files are written with the new data specification, allowing it to plan the query appropriately. So that makes life a lot easier, especially when you're working with really large petabyte-sized tables. The last thing you really want to be doing is rewriting petabytes of data because you decide to change how the table is partitioned. So that's pretty powerful. Then there's time travel. So again, you have all those multiple snapshots, those multiple manifest list files that allows you to go back in time and say, hey, let me query the table as it was at this point in time. And then basically that manifest list will point to the actual manifest that specifically define that table at that point in time. And you can query the data as it was, not as it is, which it can be very, very powerful.